Okay, now I'm going to talk to you about Hess's law. Now, Hess's law is all about giving us a way to find delta H, that's the enthalpy change, or the enthalpy of a reaction that is very difficult to actually measure. So what we do, and I actually really like this is one of my favorite things I get to do in this class, and it's because it reminds me of systems of equations that you do in algebra, where you have more than one unknown, but you have more than one equation, and you can kind of combine them and manipulate them to cancel out one of your variables. It's going to be very similar here. So this is the reaction we really want an enthalpy for, but this reaction is very difficult to complete. Maybe it's not safe. Maybe it's very difficult to actually get a numerical value. For some reason, we are not able to directly measure this. Instead, we have enthalpy values for all of these reactions that are a lot more feasible. But what we can do is we can move these reactions around so that three of them add up to this reaction. Therefore, then we add up all the enthalpy changes to get us our final answer. That sounds confusing. Honestly, the best way to learn Hess's law is just to see it. So let's dive in. The first thing we need is we need carbon as a reactant. So that means that we need to have carbon as a reactant in these reactions. So if we look through, there's a carbon, a solid carbon, and that's the only place it's there. So if you look, we need one carbon in the reactants, and there we have one carbon in the reactant. So from here on, this reaction is off limits. We are not allowed to move it around. Why? Because if we change this reaction, we're messing up the fact that carbon is in the right spot. So I'm actually going to put this in a box to remind me, I like the way that looks right now. The next thing is two hydrogens. So let's find the hydrogens. There's one. And that's it. So we need it as a reactant. We have one hydrogen as a reactant. Do we like that? No. We need two of them. So what do we need to do? We need to multiply by 2. We need to multiply that reaction by 2. So if we multiply this reaction by 2, we've got to multiply everything by 2. 2H2 is 1 O2, because 1/2 times 2 is 1, and 2H2O. You see what we did there? Now, we are now happy with this. So we don't want to mess with this, but let me talk about it. If we multiply this reaction by 2, do you remember what we also have to do to the enthalpy? Now, we also have to multiply it by 2. So negative 285.8 times 2, negative 285.8 times 2, and that's going to be a negative 571.6 kilojoules. That is now going to be our answer. Okay? Now, we got H2. Check, check. Let's hope CH4 works out well, because if it doesn't, then we're going to have to do some twiddling around. CH4. Okay, we look. There's a CH4, and that's the only place it's listed up here. We need CH4 to be in the products, but here CH4 is in the reactants. So we're going to have to completely reverse this reaction. So instead of CH4 plus 2O2 yields CO2 and H2O, it's going to be the exact opposite reaction. CO2 plus 2H2O yields CH4 plus 2O2. And now, that's now what we want. So this is now in a box. Oops, not CO2. What am I doing? Now, CH4 is exactly where we want it to be, in the reactants. Sorry, in the products. So, check. Now, if we reverse this reaction, what do we need to do to the delta H? Instead of it being an exothermic, it's now an endothermic. But the number is exactly the same. So now it's a positive 890.8 kilojoules. Here's what's so cool about Hess's law. If you did it right, every single thing should cancel, other than what we want. I put in a box the 3 parts that we want. C, carbon, plus 2 hydrogens yield 1 methane. Now, let's see if everything else cancels. we have a CO2 as a product, and here we have a CO2 as a reactant. You see product and reactant. CO2 yields CO2. Do you see how those kind of cancel? We have 2 waters as a product here. We have 2 waters as a reactant. 2 waters yields 2 waters. If we add these 3 together, those 2 cancel. Now let's look at the oxygens. We have 2 oxygens on the product side, and then we have an oxygen here and an oxygen here. Will you admit that if we added these 3 reactions, the reactant side would end up being 2O2? And look at the product side, 2O2. Do you see that those also cancel? So if we add these 3 reactions up, we end up with carbon plus 2H2 yields methane. And look, that's the reaction we want. So to get our final answer, we have to add up our 3 enthalpies that we have modified. So it would be a negative 393.5 plus a negative 571.6 plus 890.8. And we would end up with tenths, tenths, tenths. That final answer needs to go to the tenths. And it would be a negative 74.3 kilojoules. And there it is. So, there you have it, Hess's law.